Algebra 1, Section 6-2, rational exponents. So, the nth root is the square root of x. So we have the square root of x here. This is like the same thing as saying x is to the power of 1/2. So, because it's the opposite of squared, right? Because the opposite of x squared is a square root. These cancel out. So that's like saying the same thing as x to the 1/2 times x to the squared. These cancel out to make 2 over 2 because I multiply the top. So that's why this is the opposite, right? That made no sense. Just go ignore it and just take my word for it. This is the opposite of a square. So whatever the root is, okay, we have x to the 1/3. Now, here's an example. So, the fourth root of 5 is 5 to the 1/4. So, this means that we have 5 to the 1/4. The square root of 25, this tells me how much I need. It's like currency. Right? This number tells me how much I can take out. This one, I only have 1 5, so I have to leave it as 5 to the 1/4. This one has 2 5s in it. So because I have 2 5s on the outside, this is telling me 2. If I have 2 of the same number on the inside, I can represent and take a 1 on the outside, 5. This one, I need 3 numbers, 3 of the same number in order to bring it out. So 8, I can factor out to 2 times 2 times 2. So that means because I have a set of 3 2s, I can take it out and it represents just 1 2 on the outside. Okay? If it only had 2 square root of 8, that means I can only take 1 set of 2s and 1 would be left on the inside. So let's try 343 to the 1/3. This is the same thing as saying the cube root of 343. So I'm going to go ahead and factor 343. So, 343, let's divide it by 3. No. 343. Let's try 7. So I'm going to keep testing numbers. Okay, so 343 times 7. So this is 7 times 7. And then I can't factor it actually. No, it's not 7 times 7. 343 is 7 times 49. 49 is 7 times 7. So this is the same thing as the cube root of 7 times 7 times 7. How did I get the number 7? I was just playing with 343 until I got it. So because I have 3 sets of the same number and this tells me how much I can take out, that means 3 sets of the same number in here represents 1 number on the outside. So my answer is 7. Okay? So let's try the next one. We have, I'm going to do a different color. Pink. So we have the 5th root of 32 plus the 9th root of, the square root of 9. I do know that the square root of 9, this is 2, right, is 3 times 3. I could take that. Now 32 I'm going to have to factor. So 32 is the same thing as 8 times 4, which is 4 times 2, 2 times 2, 2. So that means this is the same thing as saying the 5th root of 2 times 2 times 2 times 2 times 2. So I have 1 set of 5 that I can take out, which since this is number 5, I can take out a 5 of the same number in here represents only 1 on the outside, and 2 in here only represents 1 on the outside, right? So this would be 5. Okay? Now the next one's a little complicated, and what that is we have 81 to the root of 4, but to the power of 5. So it looks like this. 81 square root of 4 to the power of 5. So let's do in the parentheses first. Let me take 81 and factor it. This is 9 times 9. This is 3 times 3, 3 times 3. So this is the same thing as saying 3 times 3 times 3 times 3 to the power of 5. Well, because I have one set, because this is number 4, that means 4 on the inside here represents 1 on the outside, so 3 to the 5th is what I have left. And 3 to the 5th is, ooh, big number, 11,907. Okay? The next one is a bit similar. All right, I'm going to go ahead and, this is the same thing as saying 3125 to the square root of 5. Again, the number on the bottom goes here, squared. So what I'm going to do is I'm going to square root this. Let's divide it by 5 first. So 5 times 6, because I know it's divisible by 5 because of the 5 there. 625. 625 divided by 5 is 5 times 125. This is the same thing as 5 times 25, and this is 5 times 5. So I have 1, 2, 3, 4, 5. So this is the same thing as saying 5 times 5 times 5 times 5 times 5 to the 5th root 2. So that means 5, the same number in here, represents only one number on the outside. So this whole thing is 5. And then I bring this 2 squared, which gives me 25. That might have been a little bit easier to follow instead of that chaos. I apologize for that. All right? The last one is a little bit easier because there's no actual numbers here. I don't have to focus on the numbers. I'm just going to focus on this. Again, however much of this is my currency. Okay, it's how much I can take out. So this says that I have 1, 2, 3, 4, right? 4 in here that I can take out as 1A. So this would be just an A. If I have B to the 20, so I have 20 B's, I'm not going to write it all out, but if I have 20 B's, how many 4's can I take out? Well, I can take out 5 sets, right? Because I have 5 times 4 is 20. So that means I'll have 5 groups of 4 B's. And every 4 B's I can take out as 1. So that means I end up with B to the 5th. All right? So go ahead and write that down. Try page 401, numbers 5, 12, and 16, 401, numbers 5, 12, and 16, and I will see you in class.